this video for Computer Science 9618 A-Level, we're going to take a look at another full Paper 4 walkthrough. The test for the fall is right around the corner, so let's go ahead and jump into this to help you be successful on your Cambridge exam. So let's take a look at number one. A source file is used to answer question 1. The file is called highscore.txt. Now remember, before your exam even begins, your test examiner should have given you your evidence document, which is digital, and they should also be providing you with this source file. It is impossible to fully answer this question and earn all marks without this source file. Once they give it to you, it is your responsibility to make sure it goes in the right part of your program. It goes in the debug folder, and I have videos on where that goes and how to do that. Let's take a look at this question. The text file, highscore.txt, stores the players who have scored the top 10 scores in a game in descending order of scores. So it's in descending order. Now, when you get your paper 4 exam and you actually get the physical paper copy, you can actually write anything you want on this paper. Now, none of the code that you write on your actual paper will be graded. So if you need to make some notes or mark some things down, do so quickly, but I wouldn't spend lots of time writing code. Remember, you only have 2.5 hours, and it's going to be a very, very quick 2.5 hours. The file stores the 3-character name of the player and their integer score in the order player followed by score. For example, the current top player in the text file, FYI is the player name. Right next to that is his score, 10,000. So the program reads in data from highscore.txt. Remember, that file will be provided to you. You do not want to make changes to that file. If for some odd reason you do make changes to the file, go ahead and ask for a brand new source file. That way you have it working how it's supposed to be. Allows the user to enter a new player name and their score. I'm sure we're going to be doing that. If appropriate, inserts a new player name and their score into the top 10. I'm sure we'll be doing that too. Remember, it's going to be in descending order. We need to know that when we're trying to insert that score into the right spot. Writes the top 10 players, their name and their score, into a new text file, new highscore.txt. This is a file that will not be provided to you because you'll be writing that file. Remember, anytime you write to a file for the first time, if it doesn't exist, it will create it for you. If you're trying to read from a file that doesn't exist, your program will crash. So make sure to keep that in mind. All of this is not for part A. That's for the entire program, and they've broken it down into separate parts that we'll code out section by section. So for part A, the program stores the players and their scores in an array of 11 elements. 10 elements to be read from the file, 1 element to be inserted by the user. Write a program to declare 1 or more arrays as global data structures to store the player names and their scores. What I find very interesting here is they give you a choice that you can declare 1 array or you can declare multiple arrays. Why in the world would you want to do that? Well, you have a couple options of how you want to set this up to answer. I'm going to use 1 2-dimensional array. That's because I want 1 array to work with. The other way to do it is to have 2 1-dimensional arrays. You have a 1-dimensional array that holds the names and another 1-dimensional array that holds the scores. We call these parallel arrays. That means what is in index 0 of the name array corresponds to index 0 in the score array. So FYI would be in index 0. His score would be held in a separate 1D array that's holding his score. I want to use a 2D array, so I only have 1 array to work with. When you have multiple arrays that you start working with, it can get a little tricky and a little messy very quickly. So let's swing over to vb.net and let's show you how to code this out. All right, so we're over in VB. We are making sure we're outside submain because it does say global. I'm going to call my 2D array high scores. Now I'm going to need a max index of 10, because remember, if we start at index 0 and count to 10, those will be 11 rows. We have 10 names we need to record from the file, and then one that the user is going to enter. So I need to make sure I have 11 rows to work with. The next number is columns. I need a max index of 1. Again, I'm going to use index 0. Why do we need 2 columns? Well, we need one column that's going to hold the name. The next column directly to the right of it is going to hold the high score. Now, what about the data type? Because one's a name and the other one is an integer. Well, we're going to make this as a string, and if we need to convert that score to a number later on, we can. But that is how you declare the 2D array to set up for question A. Let's go ahead and take a look at part B. The procedure read high scores opens the file highscore.txt and reads the data into the data structure, that's that 2D array that we declared in part 1a. Write program code to declare the procedure read high scores. Nothing that you can't handle. Let's swing over to vb.net. Let's do it right now. So we create the procedure, which means a sub, and they give us the name read high scores. No parameters, no return data type. So just like that, we have it. Now I need to go to the very top here. I'm going to import my system.io. That is so I can do this part right here, dimensionalize a file handle as a stream reader. That's why I import that system.io. Not only do we need a file handle, we also need row as an integer. We're not using a for loop here. We're going to be using a post-conditional loop. Now, you could use a preconditional loop. If it works, Cambridge will give you points. But because our loop is going to run at least once, it's most appropriate to use a post-conditional loop. We're going to go through each line and we're going to record the names in each row, column 0, and then the high scores in each row, column 1. So that's why we have row. We can revert from 0 to 1 and 1 back to 0, but having a variable to handle that requires a lot of unnecessary calculations. With a row, I can just simply input that one time and increment it by 1. So we want row to start at 0, and it's at 0 by default. If you want, you can do row equals 0. Is that required? No, it's not. I'm not going to do that because it's already at 0 when it's created. Anytime we're trying to read a file, we know we want to use a try-catch statement. If you've watched any of our other Paper 4 walkthroughs, you know that when we read a file, we use a try-catch statement. So what I'm going to do here, so I'm going to do file handle equals new system.io.stream reader, and then I need to put the name of the file, highscore.txt. Now I'm going to use a post-conditional loop. So I'm going to do loop until file handle dot end of stream. Now, one thing that a lot of students forget to do is they forget to close the file. Right after I exit this loop, I'm going to do file handle dot close. Go ahead and do that just so you don't forget to do it. Also, we're going to handle that exception if the file's not found. We're going to output a message such as file not found. Now, let's go ahead and code out everything we need. And it's not a lot because the loop's going to do most of it for us. So we're going to be using this 2D array that we created up here. So what I'm going to do is I'm going to do high scores, row, comma, 0. What's in row 0, column 0? Well, I know that is going to be the name. So I just do file handle dot read line. Then I do high scores again, row, but this time I'm getting column 1, which is their high score. File handle dot read line. So this is the name of the player, and this is the player's score. So it works just like a table. Now, this is very important. We don't want to overwrite what we just got, so we want to increment row by 1, and then we'll go 10 times because that's how many names are in the file. So just like that, we're done with part 8. Not a lot of code here, but we picked up 6 points. Don't forget to close the file. That is the number one thing that people forget. If for some reason you're in the middle of the test and you get file not found, the first thing you want to check is, did you move the text file, the source file they gave you, to the right location? Remember, you just keep going all the way on the top folder till there are no more folders. I've shown you this in other videos. Make sure it's pasted in there, and then make sure the next thing you want to do is make sure it is spelled correctly, because if you misspell this, say highscores.txt, well, that's not the name of the file. It's not going to open. So if your file's not opening, those are the first two things you want to check. Make sure we have our in sub. We do. So we have everything for part A and B now. We've earned 8 points on our paper 4 exam. Let's take a look at part C. The procedure, output high scores, outputs all the values in the data structure or structures in the following format. We have player name followed by the score. Notice it's on the same line, and they even give us examples. The first two data items, FYI 10,000, ABC 9,092. As a reminder, remember, these scores should be in descending order. Now, because we're pulling it from the highscore.txt file, it will already be in descending order. Write program code to declare the procedure, output high scores. So basically what they're saying is, hey, we want you to output that 2D array. So let's swing over to vb.net and earn 3 more points on our paper 4 exam. All right, we're going to create another procedure. So I'm going to get rid of some of that space there, move this down so we can see it. And we have output, and we want to spell it correctly, high scores. No parameters, no return data type. So all we need to do here is run a for loop. Now, with the 2D array, usually you use a nested for loop. We don't need to do that for this one. So we're going to do for I equals 0 to 9. We don't need to output the 10th one, because there's nothing in index 10 yet. That is for the user to enter a player name. So we simply do console.writeLine. What are we outputting? We're outputting the high scores. What row? Row I. What column? 0. But we also want to output a space because they had a space, and we want to output high scores. Row I, but this time column 1. So this will output their name and their score. So just like that, we're done with part C. We picked up 3 points. We now have a total of 11 points on our paper 4 Cambridge exam. So we're moving them right along. So let's take a look at part D and see what they want us to do next. The main program should first call read high scores and then output high scores. Well, that makes sense. You got to read and put it in the 2D array before you can output it. Write the program code for the main program. That means write it in submain. Then they want us to test our program. Take a screenshot to show the output from this part right here where we call read high scores and output high scores. Not a problem. Let's swing over to vb.net, add those 2 lines of code, and then run it so we can see the output. We move to our submain, which is the main program, and we call read high scores. We call output high scores, just like that, and we're going to save our code. We're going to run it, and we should see 10 names. So we see FYI. So let's count how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have all 10 names. Now, if you run your loop 11 times, you're going to have a space down here at the end. That's okay because it's still outputting the names. But make sure you're using the appropriate code. All the scores are in descending order, so this works exactly like they want, and even the first 2 examples that they have matches what we have. Let's go ahead and move on to the next part of the Cambridge exam. The main program needs to ask the user to input a new player name and a score. If the score is in the top 10, it will create a new top 10 list that includes this score. Then the main program to ask a user to input a 3-character player name and an integer score that must be between 1 and 100,000 inclusive. When I look at that, I can only think of one thing. These players are not very good. If 100,000 is the highest score possible and the high score is 10,000, these players are not very good at the game, but that's okay. So we're going to do that, and then they want us to write a program code to declare a procedure that takes the player name and score as parameters, creates a new top 10 list that includes the parameter if appropriate. So we're going to handle both of these and pick up an additional 8 points on our Cambridge exam. Let's swing over to VB.net and code each of these out. So we go back to our main program. I'm going to do P for player name as string, and then I'm going to do P score as an integer. There we go. So all we need to do now is we need to ask them to enter their name. So enter your name, and we'll say 3 characters. And we'll keep asking them until they enter a name with 3 characters. So we'll do that in just a moment. So P name equals console.readline. Then I'm going to do the same thing and ask them to enter their score. I'm not sure what kind of game it is where the players enter their score, but companies can do whatever they would like. So we're going to do console.readline. Now, what we need to do is have this loop. Because our loop's going to run at least one time, a post-conditional loop is most appropriate. So we're going to loop until pname.length is 3. Once it's 3, then we know they've entered the right amount of characters. Down here, we're going to we're going to loop until the score is in the appropriate range. It has to have a minimum score of 1. So score needs to be greater than or equal to 1, and the score needs to be less than or equal to 100,000. So make sure you have enough zeros there. It's between 1 and 100,000 inclusive. So that's why I have greater than or equal to 1. You can do greater than 0 if you would like. I'm not. I'm just going to keep the inclusive ranges there and use greater than equal 1 and less than or equal to 100,000. Now that we have P name and P score and we know it falls in the correct range, in the correct length for the player name, we can pass that down to the other procedure that we're going to create right now. So we're going to create that procedure, sub update, I want to spell it correctly, high scores. Now it does take 2 parameters. The first one is going to be P name. I'm going to call that name as string. I'm going to call the second one score, and that's what P score. Score will make a copy of P score. That's going to be an integer. Now we're going to need to convert that to a string later on, but I need to leave it as an integer so I can compare correctly. So I need to traverse all the scores and find out if score is higher than any of those scores. So we're going to do for I equals 0 to 9. Now, if score is greater than high scores, I, 1, then something happens. What I need to do is, if that score is higher, I'm inserting somebody new. That means before I insert them, I need to shift everybody down by 1. For example, let's say score is a new thing that's in 8th place. That means whoever was in 8th place needs to shift down to place 9. Whoever was in place 9 now needs to shift down to place 10. The person in place 10, they don't get placed because we only have index 0 to 9 for 10 people. So we need to shift everybody down. So we're going to do for j equals 9 to I plus 1, step -1. What is this doing? This is counting down. For example, let's say this guy is in 8th place. Well, then I only need to run from 9 to 9. It's only going to run one time. If this guy is in index 7, then we need to go 9 to 8. We need to shift everybody down. So here's how you do that. We're going to do high scores, J0, that's going to be the name. What are we putting there? The person who was above that previously, because we need to move them down. So that's going to be high scores, J -1, 0, that's going to be their name, but we also need to shift their score down. That's going to be J1. What are we putting there? The person's score who is there right above it, J -1, 1. Now, once we have done that and we've shifted everybody down, we can now put in the new high score and the new name. So all I need to do here is high scores, I, comma 0. What am I putting in there? Name. High scores, I, comma 1. What am I putting in there? I'm putting in the new score. Now, once we do that, it's been placed. We don't need to go anymore through this outer loop. And just like that, this right here, this inner loop will shift everybody down. I need to shift, if I'm in first place, if score's first place, I need to shift the person in index 0 down to index 1, the person in index 1 down to 2, the person in index 2 down to 3. But we want it to be efficient, and that's why we have this I plus 1. We only need to go as far and shift everybody down based on what I is when the score is higher than the current high score that's currently there. Then, after I've shifted everybody down, I have made room for the new name and high score, and we exit that loop because it's only going to go in front of one person's score. So we don't need to keep traversing everybody else's. So just like that, we're done with that part of the question. Let's take a look at the next part of the question. I'm in the main program to call the procedure from part 1E2. That's output high scores. Output the contents of the array before inserting the new player name and score. Output the contents of the array after inserting the new player name and score. Test your program by entering the player name, JKL, and the score 9,999. Take a screenshot to show the output. So let's go over how that inner loop works, and then we'll make the call. So here is our text file here, and we're talking about this inner loop. It's a little hard to understand abstractly what's going on, so I want to show you what this text file is actually doing. So we're starting at index 9. Remember, this is index 0, index 1, 2, 3, 4, 5, 6, 7, 8, 9. The new person we're going to enter has, which is JKL, with a score of 9,999. That means I need to start at index 9 and shift everybody down. Well, it only goes to 9, so this is going to be gone because what I'm going to put where DIS was, I'm going to put EIF there. So this is what's going to happen. EIF is going to move down to where DIS was. Then we decrement by 1. That means JSI is going to move down. JKL, it's going to, or GKL, it's going to move down. So we won't have these spaces here. ACE, it's going to move down, or ACE. All of these are going to essentially move down. We need to move the score and the name. What's eventually going to happen is everything is going to shift down. And then right here, we're going to have JKL and 9,999. And this is what our text file is going to look like. Remember, it holds 10 high scores. 0, index 1, index 2, index 3, index 4, index 5, index 6, 7, 8, and index 9 for the 10th high score. Now, when that happens, I don't know why Cambridge wanted us to create one with 11 indices, because we're never going to use that 11th index because it only holds the new high scores. It doesn't hold the old ones. But anyway, we're going to update the new high scores, and that's how it works. So now what we need to do is we need to call the procedure and make sure that it works. So we can see that we read the high scores, we outputted it, we get the user's information. Then what we need to do is update the high scores. Then what we need to do is we need to output it again. So output high scores. Now remember, output high scores has 2 parameters. So I don't need to do by val there. I just need to put in the argument name, p name, and p score. Now remember, score needs to be an integer when you pass it down, and we need to convert it to a string when we're done. There we go. I'll put a note in the video to make this to string. This needs to be a string because our 2D array high scores is a string, and that's how you convert it to a string. Just put in .to string. So let's go ahead and let's save our code. And when we run it, everything should shift down. So here's the text file, JKL 9,999. And we can see everything shifted down. Again, This inner loop, in case you're confused by this, because very rarely do we count down. Usually we're starting at a lower bound and going to the upper bound. This time we're starting at the upper bound and working our way to a certain number. We took what was in index EIF. So we started at 9. What are we putting in index 90? Well, in index 90 is DIS. And index 91 is 2000. What are we putting in there? Because we need to shift EIF down. Well, in index 9, column 0, what am I putting in there? I'm putting in J-1, which is index 8. What am I putting in there? Column 0, which is the name. Then I'm updating the column 1. What am I overriding with 2000? Well, index 91 is 2000. I'm putting in high score J-1, which is 9-1, which is 8. What is in 8-1? 6003. And where am I putting that? I'm putting that in index 9. So here you can see EIF has made its way down, and then it keeps decrementing all the way until we get to index JKL. Once ABC moves down, we don't need to move anything else because we know JKL is going there. So again, that's how that inner loop works. It's a little hard to understand abstractly, so that's why I wanted to show you what's happening so you can have a firm understanding of what my code is doing. Let's take a look at the next part of the question. The procedure write top 10 stores the new top 10 player names and scores in a text file called new high score .txt. Write program code to declare the procedure write top 10. So what we're going to do is simply write code to take that 2D array and simply store it into a text file. Let's swing over to VB.net and pick up the last part of these points for question 1. All right, so we need to create that procedure, write top 10, no parameters, no return data because it is a procedure, not a function. So we're going to do file handle as a stream writer. Now, anytime you're writing to a file, you don't need a try catch statement. If the file doesn't exist, then we'll automatically generate that file for you. So you don't need to do a try catch statement when you're writing to a file. You only need to do a try catch statement when you're reading a file. So all we're going to do is file handle equals new system.io.stream writer, and then we put in the name of the file, and they wanted us to call it new high score. So new high score, and yes, you have to put the .txt. All we need to do now is run a for loop that will traverse through the rows and the columns. Now, if you want to use a nested for loop, you can, because we only have 2 columns. I'm going to do it all in one for loop. And you want to put your for loop in the right spot. So for I equals 0 to 9. So I'm going to do file handle dot write line. And what am I writing on that first line? Well, that's going to be the high scores. And I want to access row I, column 0. I'm going to do the same thing on the next line for their score. What am I putting on that next line? High scores, row I, column 1. Now, if we had more columns, rather than writing all of them, we would simply do a nested for loop. Can you do a nested for loop here to handle the 0 and 1? Yes, you can. Either way is fine, but don't forget, you have to close that file. So just like that, we're done, and we're going to go up here to our sub main. We're going to do write top 10, and then it will call that procedure and it will write that file. But that's going to wrap it up for question 1. Let's take a look at question 2. And notice for part F, the part we just wrote, all we have to do is write program code to declare the procedure write top 10. We did not actually need to write it in submain and run our program. So we just had to paste that one section or that one procedure into our text document. Now, if you wanted to run it to make sure it works, you definitely can do that. Let's take a look at number 2 though. A computer game is being developed using object-oriented programming. One element of a game is a balloon. This is designed as the class balloon. The class has the following attributes and methods. So we see that we have some attributes here or properties. We have health, color, and defense item. Health is an integer, color, and defense item are strings, and they give us a little bit of a description here. The methods you definitely want to read, especially this constructor, because it tells you if it accepts parameters or not. Initializes the defense item and color using the parameters. So right there we know the constructor is going to accept two parameters, being the defense item and the color, and then initializes health to 100. Health is not going to be a parameter, it is an attribute, but we're going to set it equal to 100 when the constructor is called. So inside the constructor, we're not accepting health as a parameter, but we're simply going to do health equals 100. Then we have change health, takes the change as a parameter and adds this to the health. Get defense item returns the defense item of the object, and then we have a check health method. If the health is 0 or less, it returns true, otherwise it returns false. So now we can take a look at part A. Remember, up here, this is going to be the name of the class, this is going to be the attributes of each object, and the method. So part A, the constructor takes the name of the defense item and the balloon's color as parameters and sets these to the attributes. The health is initialized to 100. Write program code to declare the class balloon and its constructor. Do not write any other methods. Use your language appropriate constructor. Here it reminds us that all attributes should be private. They may or may not tell you that. Regardless of whether or not they tell you all attributes should be private, you are going to make them private regardless of whether they tell you that or not, because that's the general rule for attributes in object-oriented programming. So let's swing over to VB.net. Let's declare these attributes in the constructor and start building that class. All right, so we're going to start creating that public class balloon. So just like that, we can pick up a point. Now we need to make all our attributes private. There was health, which was an integer. There was color. Now I'm going to spell color like they did. That is a string, and then defense item. They spell that with a C. There we go. Now, that's it for the attributes. Then we have to create the constructor. The constructor will forever be public sub new. When we create a brand new object and we use that keyword new, so in this case it'll be new balloon, it calls the constructor, this method, new. Now, public sub new will always be our constructor. It may or may not take parameters. How do you know whether or not it takes parameters? You look at that description in the table and it will tell you. And in this one, it took two parameters. So I'm going to do by val C as string and by val D as string. That is for the defense item in the color. So my color is going to be equal to C. My defense item is going to be equal to the parameter D. And what do we do with health? We set it equal to 100. Just like that, we have done everything to declare the class. We have our attributes as private, public sub new, which will always be our constructor. And in this example, it takes two parameters, one for color, one for defense item. We set those equal to those attributes, and we set health equal to 100. So that's going to be it for part A. Let's take a look at the next part of this object-oriented programming question. The get method, get defense item, returns the defense item of the object. Get methods will always return a value, which means they're always going to be a function. As long as you return defense item, you're going to get your second point. So let's swing over to VB.net and quickly pick up these 2 points. All right, so all we need to do is public function, and then get what? Get the defense, and I'm going to spell it like they did. Defense item, just like my attribute is. Get methods do not take any parameters generally, and this is going to return the data type string because my defense item is a string. Return defense item, and just like that, we've picked up the 2 points for writing the get method. Let's take a look at the next part of this question. The object's method, change health, takes an integer number as a parameter and adds this to the health attribute of the object. I'm in your program code to include the method change health, so we're going to write that method. Then part D, the object's method check health, returns true if the health of the object is 0 or less, meaning no health remaining, returns false otherwise, meaning health is remaining. And in your program code to include the method check health. Let's go ahead and write both of these methods right now. So we're going to write change health first. That's going to be a sub change health. And that does take a parameter here. So we're going to do by val amount as integer. Doesn't return anything, and all we got to do is increase the health by the amount in the parameter. So just like that, we're done with change health. Then the other method is going to return a Boolean value. So that's going to be a function, and that is called check health. No parameters, it returns a Boolean data type. So all we got to do is check to see if the health is less than or equal to 0. If it is, we're going to return true. And then if that if statement doesn't run, we're going to return false, because if it's not less than or equal to 0, we need to return false and let them know that there is still health remaining. So just like that, we have written the two methods that they have asked us to write. We've picked up 4 points. Let's take a look at the next part of this question. Amend the main program, so that means sub main, amend it to take as input a defense item and color from the user. So we're simply going to ask them to enter a defense item and a color. Create a new balloon with the identifier balloon1 using the data input. So let's swing over to vb.net. Let's get that input and create an object. All right, so we're going to need two variables. I'm going to do dimd item for defense item as string, and then I'm going to do color as string as well. And that is for our constructor. Remember, when we create a new item, that public sub new, it passes the defense item and color as parameters. Now, color was first, so I need to make sure I pass that first. Then we need to get some information from the user. So we're going to say enter the color. And then what I'm going to do here is I'm going to do color equals console.readline. And the reason I want to get the color first is because if I look at my constructor, I passed color first. So that's just for me. I can do this in any order that I want, getting the information from the user. But this reminds me that I need to pass color first. Enter the defense item. And then I'm going to do d-item equals console.readline. Then what I need to do is I need to create a new object. I don't like putting dim after this. I always like doing it at the top. I like dimensionalizing things at the beginning, but we don't have that option here. So I'm going to do dim balloon1 as new balloon. Now, you're going to see that we have a red line. Why do we have a red line? That's because when we look at our constructor up here, notice that it takes two parameters. I have two things inside the parentheses, which means I need two things in the parentheses down here. I need to pass color, I need to pass the item, and when I finish typing in the second item, that red line has gone away. Just like that, we amended submain. We got input from the user. We stored it, and we created a new object, balloon1, with the values that the user supplied. Let's take a look at the next part of the question. The function defend takes a balloon object as a parameter, takes as input the strength of an opponent from the user, uses the change health method to subtract the strength input from the object's health. So we're going to need to multiply that by -1. So when because remember, it's added on to health. Well, we need to add a negative number, so it subtracts it, outputs the defense item of the balloon, checks the health of the object, and outputs an appropriate message. If it has no health, meaning it died, or if it has health remaining, survived to fight another day, returns the amended balloon object. Now, because we're amending the balloon object, we don't want to pass by val. We want to pass by ref. If we pass by val, then it's going to make a copy of the object. We don't want to do that. It says to return the amended balloon object. So we want to do it by ref, so they give us the points that we earn. So let's swing over to vb.net and let's code out the function defend right now. So we're going to create that function defend, and it takes a parameter. What parameter is it taking? It's taking an object parameter. So I'm going to do by ref, give it a name, my balloon. But what data type is that? Well, that's a balloon data type, and it returns an amended object. What is the data type of the object it's returning? And it is balloon, just like that. So nothing to stress about. Just do it like you normally would. The data type is balloon. We need strength as an integer, and we're going to ask them to enter the strength. So enter the strength. of the enemy. And then we're going to store that. Now, once we store it, we need to multiply it by -1. Because remember, in our check health or change health method, it adds an items. I don't know why they just didn't subtract it to begin with, but that's okay. We're going to do strength times equal -1. So that'll change it to a negative number. So when we take a positive and we add a negative, it'll be like it's subtracting. So we need to do my balloon dot change health, and we need to pass strength, which is now a negative number. The next thing we need to do is we need to output what we defended with. So you defended, and you want to spell all these things correctly with, and then we're going to get the defense item. So my balloon dot get defense item. So that will display the defense item. All we need to do now is check to see if they're still alive. So we're going to do if my balloon dot check health equals true, then we're going to say you died. So you died, because that means they don't have any health left. And then, oh, you know what? It's not change health. It is check health. There we go. And then console.writeLine. You survived to fight another day. Then we need to return that amended balloon object. So we're going to return the object name that we gave it, my balloon. So just like that, we get the strength from the user. We multiply it by -1. So we'll subtract that from the health when we call the change health method. We output their defense item that they assigned earlier when we created the object. Then we check their health. If it returns true, they died. If not, they still have health, so they survived to fight another day, and we return the object that we passed as a parameter. Let's take a look at the next part of the question. I'm in the main program to call the function defend. Test your program by using the following inputs. So for the balloon fence method, we're going to type in shield. The balloon color is going to be red. The strength of the opponent is 50. Take a screenshot to show the output. So let's swing over to vb.net and do that right now. So we need to call defend. Defend returns a balloon data type, and it's returning the balloon that we passed down. So we're going to do balloon1 equals defend, and we're going to pass down balloon1 because it's about to lose some health there. So what we're going to do is we're going to save our program, we're going to run it, and we're going to enter the attributes it told us. So they wanted red. Our defense item was a shield. Enter the strength. They said 50. You defended with shield, and because 100 minus 50 is 50, we survived to fight another day. That wraps it up for question 2. Let's go ahead and move on to the final question of this paper 4 exam. A program uses a circular queue to store strings. So that is the abstract data type that they chose for this paper 4, which is a queue, and they want a circular queue. So we'll code that out. The queue is created as a 1D array, queue array, with 10 string items. The following data is stored about the queue. So we have head pointer, tail pointer, number of items, and they're all initialized to 0. We have to declare the array, the head pointer, the tail pointer, and number of items. It doesn't say it's global, so we're going to make it a local, which means it's going to go inside sub main. Now, for the abstract data type, they're going to ask you about a queue, either a standard queue or a circular queue. They could ask you about a stack. They could ask you about a linked list. They could also ask you about a binary tree. So you want to make sure you can program all of those, and I have videos on those as well that walks you through how to program each one. But for now, let's go ahead and let's code out part A so we can pick up these 2 points for this part of the question. So the first thing we need to do is dimensionalize that queue array. It holds 10 items. I'm going to have a max index of 9. When I count 0 to 9, that will be 10 items. The next thing I need is that head pointer. That is an integer. The tail pointer, that is also an integer. And my number of items, that is also an integer. All 3 of these are going to be set to 0. So head pointer equals 0. My tail pointer equals 0. And my number of items also equal 0. So just like that, we're done with part 1. Let's take a look at the next part of the question. So part B, the function enqueue, and enqueue simply means we're adding an item to the queue, is written in pseudocode. The function adds data to add to the queue. It returns false if the queue is full, returns true if the item is added. The function is incomplete. There are 5 incomplete statements, and there is a ton of parameters here, and it's going to return that Boolean value. So it's going to pass the queue array, the head pointer, the tail pointer, number items, and the data to add. Now, do you have to fill this out? Absolutely not. If you fill this out correctly, you will be awarded 0 points. This is to help you code out the circular queue. Do they have to give you pseudocode for the abstract data type? No, they don't. I have seen another paper 4 exam where we had to write a circular queue and they did not give us any pseudocode at all. So don't be thinking that you're going to get the pseudocode and just be able to code it out when you get there, because you're not always going to have it. So we're going to fill this out and then we're going to translate it to code using VB.net. Now, if the number of items is equal to 10, that means it's full. So what is it going to return? It's going to return false because there is no room. Now, what about queue array blank the data to add? Where are we adding that? Well, the head pointer holds the next item to be removed from the queue, so we need to add it at the end, which is the tail pointer. Then if tail pointer is greater than or equal to 9, we need to reset that tail pointer because it's a circular queue. So if the tail pointer is greater than or equal to 9, we need to reset it back to the beginning, which is 0. Else, we're going to increment that tail pointer by 1. What did we do with number of items here? We simply add 1 to it because we've increased the number of items. We return true because the item was added successfully. Let's swing over to VB.net and let's translate this to code. All right, so we're going to do function enqueue, a fancy way of saying we're going to add something to our queue array. Now, this needs to be done by ref. If we do it by val, that means we're going to make a temporary copy of the array, the tail pointer, number of items, and we're not going to make a permanent change. We need to permanently change it because we're going to be updating it. So we want to do by ref, not by val. We need to create a queue array. So I just put a set of parentheses. Nothing goes inside the parentheses after the word queue. That just says, hey, you're going to have an array called queue. I also need to do the tail pointer. That's an integer. I also need to do number of items. So they called it number items. Now the last one I can do by val or I can do by ref, and that's the data to add. And that is a string. This is going to return a Boolean value, this function is. So we have our header. Now, the first thing we need to do, we check to see if the queue is full. How do we do that? By using the number of items. If number of items is equal to 10, then what we're going to do is we're going to return false just like they did in their pseudocode. Now, if we don't return false, we're going to update that queue. But what index are we updating? The tail pointer, because that holds the next index of where we can put that data to add. Now, once we've added it, we need to check to see if our tail pointer is at 9. If our tail pointer is greater than or equal to 9, then what we need to do is we need to reset that tail pointer back to 0 because it is a circular queue. It's very important that we add it to the queue before we reset it. If we reset it and then add the tail pointer, we're never going to use index number 9. Now, if it's not at 9, then we're going to increment tail pointer by 1. Once that happens, we're going to increment number of items by 1, and all we're going to do is simply return true because that will update the queue because and tail pointer and number of items because we did it by ref. That will wrap up the function for this part. Let's take a look at the next part of the question. The function Dequeue returns false. Now, it's very important to know that false is in quotes, so that's going to be a string data type that it's going to return. It's not going to return a Boolean value. It's going to return false in all caps with quotes around it. That means it's a string data type. So the function Dequeue returns false if the queue is empty or it returns the next data item in the queue. So write program code for the function Dequeue. So enqueue is adding items to your queue. Dequeue, you're removing the first item that was added, and that's based on the head pointer. So let's swing over to VB.net. Let's code this out. So let's build that function to remove an item, and the fancy way of saying that is to dequeue an item. So I'm going to do by ref, I'm going to do queue again as string. This time I'm going to need my head pointer. I'm going to need that by ref. That's an integer. I need number of items because I'm going to update that as well. So number of items as integer. I don't need a parameter for data to add because I'm not adding data, and this is going to return a string data type. And the reason it's returning false in quotes is because I have to return part of the queue, and the queue data type is a string. So the first thing I need to do is not to check to see if the queue is full, but to see if it's empty. So I check to see if my number of items, oh, I forgot the by ref here, by ref. There we go. If number of items is equal to 0, then I'm going to return false because that's what they wanted me to return. So I'm going to return that as a string. If it doesn't return false, then what I need to do is I need to store the item. So I'm going to do dim item as string. I need somewhere to store that item. I can't just return it because I got to update my head pointer. So it's not just returning the queue head pointer, because I have to update the head pointer. Well, how do I update the head pointer? Well, when we remove an item, if we just remove the item at index 9, which is the last index in our array, we need to swing around back to the beginning. So I'm going to check to see if my head pointer is greater than or equal to 9. If it is, my head pointer is going to reset back to 0. If it isn't equal to 9, then my head pointer, I'm going to plus equal 1. Now, I just dequeued an item. So my number of items is going to dequeue or decrement by 1. And I simply return the item. So that's going to be it for dequeuing. Let's take a look at the next part of the question. And for the last part of this paper 4 exam being 6 points, we need to amend the main program, submain, to take as input 11 string values from the user. We can do that with the for loop. Use the enqueue function to add each element to the queue, not a problem. Output an appropriate message to state whether each addition was successful or not, that is returning true or false, and then call dequeue function twice, output the return value each time. So we're going to add A through K. And when we dequeue the item, calling the dequeue function twice, when we dequeue the items in the circular queue, it should output A followed by B. That's what should be returned, and it does have us output the return value each time. So let's swing back over to our program. Let's update submain so we can do this and complete paper 4. So I'm going to go back up here to the top. I'm going to do data as string. I'm going to ask the user to enter 10 items. So I'm going to do for I equals 0 to 10 because they want us to enter 11 items because it will only hold 10. They want us to enter those 11 items to make sure we get a unsuccessful. So what we're going to do is we're going to ask them to enter the data. So enter the item you want to add to the queue. And then we're going to do the data equals console.readLine. Then what we're going to do is we're going to pass that to the queue, and the queue is going to return the enqueue, and it's going to return a Boolean value. So what I'm going to do here is I'm going to do if enqueue. Now I'm going to pass down that data. Make sure I spell it correctly. All right. U-E-U-E. Yep. Okay. So I need to pass down my queue array. I need to pass down my tel pointer. I need to pass down my number of items, and then I need to pass down the data. If that equals true, then we're going to output a message saying it was added successfully. So item was added. Then if it doesn't return true, then the item wasn't added. So we're going to code that out. Console.WriteLine. Item was not added. And then what we need to do after we input those 11 items, we need to call Dequeue twice, but we need to output it. So all we need to do is call Dequeue, and we got to pass everything down again. So we have Dequeue, we need to pass down the queue array. But this time, instead of my tail pointer, I need to pass down the head pointer, the number of items, and that's it. So we just need to output that. So I can copy and paste this twice, put an extra parentheses there to close out my number of open parentheses. All right, just like that, we've updated submain. We're getting our 11 items. 10 should be added successfully, and then this first Dequeue item should return A, then followed by B. So let's go ahead, let's save our program. Let's go ahead and run it. All right, so all we got to do now is enter the items. So A, B, C, D. Item was added. We want to see those, and we should see those all the way up to J. So F, G, H, I, and we should also see it when we type in J. Perfect. Now, when we type in K, it should say item was not added because we have 10 items in our queue. So our queue is full. We shouldn't be able to add anything. And then when we call Dequeue, because we called it twice, and the queues work on the first in, first out principle, A was entered first, so that should output. Our head pointer will move to index 1, which is holding our second item, B. So we should see that outputted as well. And that is what we see. We see item was not added. We see A and B. Hope you guys found this full Paper 4 walkthrough video helpful. If you did, please take a moment and give it a thumbs up and subscribe to help the channel grow. And we'll see you guys in the next programming video.